This video covers Higher Human Biology, Unit 3, Key Area 3, Memory. Specifically, it looks at the key learning outcomes of deciding what kind of information is stored as memory, describing how information is encoded, stored, and retrieved, giving the features of the sensory memory, describing short-term memory in terms of the working memory, the serial positioning effect, and the benefits of chunking, and finally, discussing the features of the long-term memory, including the different types of encoding. So the three different stages of memory that we talk about in the Higher Human course are encoding, storage, and retrieval. Encoding, the processing of information so that it's in a form that the brain can understand and store. The storage, the information is held in some level of the memory for a period of time. Retrieval, without this stage, memory is fairly pointless. The information is held in memory, brought back into the cerebral cortex so it can be used. The things that memory tends to occupy are our past experiences, our knowledge, and our thoughts. So these are the three different things that memory can be made up of. Okay, here we have a summary of the different levels of memory. So the first stage of memory is called the sensory memory, and it occupies the space here. All information entering the brain passes through the sensory memory and enters into the short-term memory, which is here. Sensory memory retains all of the visual and auditory input received for a few seconds, but due to that massive bulk of information, only the images and sounds which are deemed important are then encoded into the short-term memory. The short-term memory has only a limited capacity and holds information for only a short period of time. The capacity of the short-term memory can be improved by chunking. So chunking is something we're actually probably fairly familiar with. It involves grouping information into short, easy-to-remember chunks, hence the name. Phone numbers are often remembered using chunking. For example, the area codes for Perthshire, Dundee, and Alloa are respectively 01738, 01382, and 01259. So a phone number could be 01259 219 343. So you say I group that into three sections: the area code 01259, and then two three number sections 219 and 343. Bank cards also arrange themselves using chunking. So you can see 1234, 4321, 4321, 4321. The short-term memory has a limited ability to process data as well as store it for a short period of time. This is what we think of as the working memory model, and it explains why the short-term memory is able to perform simple cognitive tasks such as reading a sentence, so remembering the first half of it when we get to the second half and forming it into one word. There are many experiments which we can take part in by looking through the PowerPoint for this key area. One of these is shown above. This is the serial positioning effect. When a class of students are asked to remember a series of 20 unrelated words or objects, they don't remember the objects with equal accuracy. Those objects which were introduced first are often well remembered, as students have time during the experiment to rehearse them. So you can see of 100%, 20 numbers, 20 items, that over 80% of the students remembered these first four. As the number of objects increases, the short-term memory capacity to remember around 7 pieces of information is exhausted, and the number of objects in the middle that are remembered are fairly poor. So you can see it's dropped below 80% and it's gone down to almost zero at about the 12 or 13 point. The final few objects are quite well remembered because they're recent, so they've just been spoken of, the last 2 or 3 of them, when you're asked to write down what you saw or what you remember. As stated before, the short-term memory has around a 7-item capacity. If more information is added, then this displaces earlier information, which is lost from the memory and cannot be retrieved. Another feature of the short-term memory is that information that is remembered fades slowly over time in what is known as decay. So long-term memory has an unlimited capacity and holds information for quite a long period of time. Information must be well encoded in order to avoid the eventual decay process. So if during the time the information is stored in the short-term memory, it is rehearsed by being repeated regularly, then decay can be reduced and the number of information can enter the long-term memory. While this information is in the long-term memory, it's embedded quite shallowly. This means it's quite prone to decay. So things that are just embedded by rehearsal are not very well encoded and are shallowly encoded. Deeper encoding can be gained through elaboration and through organization, which lead to improved understanding and information retention. In elaboration, a meaningful link is added to the information to make it easier to retrieve. For example, you would assume that if I told you Isaac Newton's birth date, that you wouldn't be able to remember it, and you wouldn't remember it in a month if you were asked. However, Isaac Newton was born on the 25th of December, 1642. If we link this information to Christmas, I can almost guarantee in a month's time, if you can remember 1642, then you'll remember Isaac Newton's birthday. So retrieval is aided by what are called contextual cues. So contextual cues relate to the time and place when information was initially encoded into long-term memory. You might be gazing out the window while listening to this video and spot the number 37 bus passing your window. Every time you see that bus from now on, you'll think about elaborative encoding and contextual cues. So that's just how memory works. This is an overall summary of what we've looked at. We talked about sensory memory, how that encodes all the information that we see, but actually not for very long. Some of that, a limited amount, is put into the short-term memory, but only for, again, a very short time. The information from the short-term memory that is not encoded into long-term memory is discarded. More information can be encoded through chunking. Long-term memory has quite a long capacity and an unlimited capacity for storage. We can embed things quite well into long-term memory through elaboration and organization, and to some extent through shallow encoding, so rehearsal. Hopefully, we understand the key learning outcomes that we started with and aimed for at the start of this video. If you're having any problems with this content, please ask your teacher for help.